Hello all, welcome to my channel where we will learn all about data analytics in terms of business intelligence. I have 5 years experience into IT industry and 4 years relevant experience into data analytics and corporate training using various tools such as Tableau, Power BI and SQL. I want to help individuals learn the art of data analytics as I have learned in a simple and easiest way possible. I am from India but currently living in United Kingdom. Having recently completed my master's degree in business analytics, I have helped various working professionals and students to learn these data tools in a simple way and easiest way possible. If you like the content, please subscribe to my channel, like and share. Let's quickly jump into today's topic, which is data lifecycle. What is data lifecycle? It is very important to ask a question why a process is there. So this is very important process that we are learning today, which will help you understand data analytics in a better way possible. So to understand, as per me, to understand any process, you need to ask a question: why? Why there is a system here, right? Why there is a system? If you understand the why question, you will be able to understand what easily. So now let's quickly jump into our topic: data lifecycle. So data lifecycle is nothing but um, capturing the data from the front end applications and then doing some transformations, dumping into the staging and doing some transformations on the captured data, and then moving that clean data into the data warehouse. Now, why do we do this process and how this process is worked behind the scenes? Let's understand that. We have various parts. This process is divided into various parts. The first part is OLTP systems. OLTP systems are nothing but the front-end applications that are collecting the data constantly from the end users. For example, let's take this as an Amazon website, right? Amazon website or Uber, or it can be a Just Eats website. All these websites or applications are the front-end systems. So one application can be running on JavaScript, one application can be running with Java, and one application can be running with .NET. It depends on the region. For example, in India, the Uber Eats or Just Eats may be running on Java because Java is a robust hardware, and Java is a robust programming language. It can handle data much better. So why they are using Java in India? Because the transactions are higher in India compared to some other country, maybe a European country where the population is very less and the orders are very less. So that is why, to mitigate the overuse of the resources, the companies use different programming languages to process the data, right? So now we understood what is OLTP systems. OLTP systems are nothing but collecting the data from various users, or the data is generated in the application. For example, you can take um, you can take an example of a manufacturing unit where all the machines are running and the sensor data is automatically populated from the machines, and the application will capture that information and process that information within the application. So before we get into the whole data lifecycle topic, let's think about a simple analogy, right? Let's take a simple analogy and to understand the whole data lifecycle. For example, you're not working today and you feel like you want to make a good vegetable soup. Now, what would you do? You will obviously you'll obviously go to market and then pick up your vegetables and then bring them to your home and then cut them into pieces and then cook your soup with all the ingredients to make the taste better, make the soup taste better, and then you serve it to your family members or you may have it alone. So The whole data life cycle process is similar to that. Yeah, it's very similar to how you make a soup. Now let's understand each part. The first part, as we know, are the front end applications, and the second part is nothing but ETL systems. And what is ETL? ETL stands for extract, transform, and load. So we know the part extract, and we don't know the part transform and load. Of course, load is nothing but you're loading something, isn't it? You're moving one thing to another thing. That is called loading. You're moving one thing from one place to another place. That is also called loading. So what is the meaning of transform here? So this is very important. So obviously we will be taking all the data from the front end applications and with the help of SSAS, and we will be loading into staging server, right? Now transformations can be as simple as, while you're taking the data from the OLTP systems, you found that there is an issue with the data type of there's an issue with the data type for a particular column or maybe a collection of columns, and you're correcting the data type for it. Or you can be merging couple of columns, maybe the first name last name, into only one name. You can be doing splitting the columns, or you can be merging the columns, you can be joining the multiple tables, you can be doing any other these are all the transformations that are available in the SSAS. And using this, you will transform the data. You can also be creating new data out of the existing data. But whatever the data is available in the OLTP system, this is completely raw data. It doesn't have any standardization. Now we are bringing in all that information using the SSAS and doing extract, transform, load, and then putting in the staging server, right? You'll take all the data and then put it in the staging server, and then from there you will do the whatever the transformations you're doing, you will be doing it in this part. You will not be doing any transformations at this stage, like at this stage or at this stage. I'll tell you why we don't do any transformations at this point and at this point. Because OLTP systems, mainly their storage capacities is ranging somewhere from 300 GB to 500 GB. So these systems can only store up until 300 to 500 GB. So these systems are constantly working, right? So these systems are nothing but SQL servers. Behind the scenes, all the programming language behind the scenes, there is a SQL server that is running. So we are connecting to that SQL server and we are taking the data from these OLTP systems. Now you're putting a lot of load on the OLTP systems because it is already running the front end operations, and you're also looking to do back end operations with the servers. This is going to create a huge performance issue. Hence, the user experience on these applications who are connected will be hampered. That is why we will never touch these systems for reading the data, right? We are reading the data. When we are taking the data out of it, we are reading the data. So what we will do is simply we will delete all the data, and using the ETL, we will just store all the data into the staging server first. This is also another SQL server, right? On top of the SQL server, we will do all the ETL operations, whatever the business rules, business integrity, business logics, all the logics and business requirements. We will do all those operations using the staging server rather than doing it using the front end servers, which will impact the performance. So let's understand how we will take all the data from here and then store it in the staging server. Now it's like you going to a vegetable vendor right? You're going to market and collecting all the vegetables, whatever the vegetables you want for the soup from different vendors, and then you're putting it in a you're bringing them into your kitchen. So think like think this is like your kitchen, right? Whatever the cooking and everything is done here in this stage. Now let's understand. We have understood OLTP systems. We have understood ETL, right? We have understood staging server as well. Staging server is nothing but it's an SQL server where you will keep all your OLTP data. You will dump the all the OLTP data into a staging server, and then on top of it, you will connect SSIS package to staging server, and then do all the ETL transformations. Now let's understand what is SSS. SSIS stands for SQL Server Integration Services. This is an application or this is a software package that was given by Microsoft to do your all ETL operations. So normally we will use SSIS for on-premises servers, on-premises SQL server. We will connect to on-premises SQL server and then we will do ETL operations. But nowadays, many organizations are moving to cloud infrastructure because of the scalability and because of the fast performances, because of a lot of advantages that comes with the cloud. Especially the managing part is very easy. So that is why most companies are moving to cloud infrastructure compared to on-premises servers these days. So now in cloud environment, we have something called ADF or we have Databricks. These two tools are similar to SSAS, and these two tools carry out same work similar to SSAS, but in the cloud infrastructure. So now you know what is SSAS. Now you know what is ETL. Now you also know what are the OLTP systems and what are the purpose of OLTP systems, right? Now the data is completely stored in the staging server. Now there is a catch here. Let me explain you one thing. Now we can only most companies actually keep 3 months of data, and then each month they will transfer the data into staging server. For example, if we have January data and February data and March data in our OLTP systems. Now on March 31st, right, the SSIS package triggers. It is scheduled to run on March 31st. And what it does, it takes all the January data, it deletes all the January data inside the OLTP system and then dumps it into staging server. Now we are left with February and March data inside the OLTP, and on April 1st, the April data starts to accumulate inside the OLTP systems. Right now, there is something called incremental loading that we will use. So we will use incremental loading logic to load the data logically into the staging server, because if we take the customer tables, whatever the dimension tables inside the OLTP systems will not change, right? So you're running a business, right? You have 10 customers, and then tomorrow a new customer joins your business. Now the 10 customers are gone and only you have one customer? No, right? So you have a total of 11 customers, currently existing customers for your business. Similarly, the OLTP system has customer table who has customers, new customers, old customers. So every month, customers will not change. The transactions they make will be changed. So we will be doing incremental loading on customer table. Why? Because the customers in January will be the same customers in February as well. So we are unnecessarily, deleting all the data all the records of customers, and then we are loading all the customers again into staging server, because January customers are already existing in this staging server. We don't need January customers here. We want the new customers to be loaded in the staging server. Excuse me. So to implement that logic, we will use something called incremental loading, right? So that logic uses matching of the data, and then it will load the data into the staging server, making sure it is only loading the new data, not not repeating or duplicating the data. So let's not talk about the incremental loading right now, because that's a whole topic altogether. We have to make another video about it. Now let's only focus and concentrate on data lifecycle. Now we have connected your SSAS to the staging server and doing all the transformations, and whatever the transformations that the company requires, you have done. You have made all the changes to the data. You have created new columns, and then you are dumping the data into the data warehouse. Right? Everything looks fine from here. Now the final part is you're connecting your Power BI to tab. You're connecting your Power BI to tables inside the data warehouse. Now, data warehouse is a historical place. Let's understand what is data warehouse. Data warehouse is also called OLAP, Online Analytical Processing System. So why we call analytical processing system? Why we call processing? Why we call transactional processing? Why we call it analytical processing? Transactional processing is the system is managing all the transactions that are happening from outside world, right, from the customers. Here, the system is not processing anything. It's just storing the data here. It is also a big SQL server similar to this SQL servers, but the sorry, but the storage of these SQL servers are 300 GB to only 500 GB. But the storage of a data warehouse can range from somewhere from 1 TB to 10 TB for small to medium scale businesses, or to 300 to 400 TB for a big companies. So this is a huge database. It has billions of rows inside it. And if you directly connect Power BI to this, people used to connect it, in like in olden days. So people used to connect directly to the data warehouse and then do all the aggregated functions such as sum, min, max, and all of that processing. So what is happening here? So Power BI is directly connected to the data warehouse, and on top of it, it is running the calculations inside the Power BI. So Power BI is just a middleman, isn't it? So it's just gonna send the query, the end query, to the data warehouse, and the data warehouse is the person who is actually doing all the queries, and then you know sending the data back to the Power BI. Now, data warehouse is already being used by ETL process, already using by another teams in the company. Maybe we are using maybe we are using data warehouse for the purpose of BI, business intelligence, data analysis, and data warehouse is being used by artificial intelligence people in the company. And there is a huge load on this data warehouse. On top of it, you are actually telling data warehouse to do to do more work. So it's not viable, isn't it? So it's gonna be, at the end of the day, it's gonna be hampering your performance. It's gonna be hampering your reporting and dashboarding performance. So for suppose you have created reporting and you have created reports and dashboards and using the data warehouse, and then you have published those reports and dashboards into the cloud server such as app.powerbi.com for the Power BI environment. And now the people who are actually accessing these reports are complaining that the reports are that the reports are loading about 5 minutes. It's taking about 5 to 10 minutes to load one report. So that's gonna be a big issue. In current standards, every report that you make, right, every report that you create inside or build, every dashboard that is built inside Power BI or using any BI tool should be loading within 5 seconds. That's the standard. That's the data analytics industry standard. That means every report has to be loading within 5 minutes. Sorry, five seconds. So to make that a reality, to make 5 seconds load time, we have to do a lot of performance enhancements and everything. All this stuff we will be discussing in further classes. But for this demo purpose, let's understand that this is becoming a lot of issue. This is creating a lot of issue. Now Microsoft, brilliantly what they said is that let's create another SQL server here, right? Let's create another SQL server, and the concept is called SaaS. SSAS. So what SaaS stands for? SQL Server Analytical Services. That means, let's take an example before we understand the cube, right? So for example, you're coming from work, right? You have completed your work, you're coming home, and you called your mother to make a meal. While you're coming to home, once you're home, your meal will be ready, right? You don't have to wait any time. Your meal will be ready and your mother will be making your meal and everything is done. Now let's take another scenario. You're living alone and you go home and you have to make your own meal, right? Which option is better, this one or this one? Obviously this option is better because the meal is already ready and you don't have to delay anything. There's a virtually zero delay. So the concept of cube works similarly like that. Imagine cube as your mother, right? So what cube does is takes all the data from the data warehouse. It processes all the information, sum, min, max. It performs all the calculations and stores all the calculations and the values readily available inside the cube. It does all the permutations and combinations already, and it keeps all the data from the data warehouse into the cube already. So you don't have to directly connect your Power BI and do all the operations on top of millions or billions of rows, which takes a lot of time. So you have the data already readily available in the cube, inside the cube. You can directly connect your Power BI to the cube and then do all the calculations and transactions. Build your reports, dashboards easily without any delay, and then publish it into the server. And this alone, yeah, um, this cube concept alone has increased the loading times 10x faster. So that's the only use of the cube. It actually creates all the permutations and combinations, keeps the permutations and combinations data inside the cube, and readily available for BI tools to access it and then create the reports and dashboards on top of it. Now let's understand ODS as well. This is the final part that we are going to understand. Now ODS stands for operational data store or operational data storage. What do I mean by operational data storage? For example, tomorrow your manager comes to you and asks, hey, so I want you to make a comparison between the last week's sales, right? Last week's sales and the previous week's sales. I want a comparison of these sales. Now you have the last month's sales in the data warehouse because we are running the ETL pipeline every month, once a month. So you have all the data inside the data warehouse, the historical data. You can simply connect your Power BI or Tableau environment directly to the cube and do your reporting. But what about the last week's data? Last week's data is still available in the OLTP systems. Now you could think that you will directly connect Power BI system, Power BI environment to all the OLTP systems across the globe and get the data and consolidate it and then put it in the data warehouse and then put it in the cube and then connect it to the Power BI. That is not the way. It's practically impossible to do that, and it takes a lot of resources. It is possible, but it's not worth doing it. So what you will do? So you will create another SQL server here, yeah, and then what you will do is you will dump only 1 month data, right? 1 month or 1 week or 2 weeks data, which is readily available, which is a near real time data, and dump it into the ODS system directly from the OLTP systems. Now this enables you to do real time analysis easy. It is also a cube, right? It is also a cube like structure. So what it does is it stores all your data from the OLTP system, which is exactly for 1 week or 2 weeks. It depends on the company requirements. So it is an option. The ODS is an option to give an access to the real-time data. So what you will do, rather than connecting your Power BI to all the OLTP systems, you will just connect your Power BI to ODS, and then you will connect your Power BI to Cube as well, and then get the data from the Cube and also ODS into the Power BI system, and then do your reporting and dashboarding, comparing last week's and last month's data. So this is how you can make things work better and faster in the business intelligence environment. So this is all about data lifecycle today. I hope you guys understood the concepts well, and I hope it is helpful for you guys to start your data analytics profession. And that's all. Thank you guys.